Here we go. All right, section 2, multiplying polynomials. So just remind you where we were yesterday. Yesterday, we talked about adding and subtracting polynomials. And so essentially, all of section 1 can be boiled down into collecting like terms. Okay, x squareds go with x squareds, x's go with x's, numbers go with numbers. Okay, so whether I'm adding or subtracting, really I just have to be careful about negatives and that sort of thing. Okay, that's that type of arithmetic that you've been doing for a long time now. Okay, in this section, now we're going to be dealing with multiplication. And so multiplication, again, an operation that you are more than familiar with. Yes, you are allowed a calculator both for the assignments and for my tests, that sort of thing. So this should be pretty deep review for you guys as far as how to do the main strategy of this section. The main strategy for this one is going to involve the process called distribution, something that will be illustrated in these first couple of examples. And I've kind of shown like a nice little progression of difficulty here. We're going to be focusing on this stuff in this example, in this section, and in these notes. But I'll show you kind of where it develops from, stuff that you guys have been doing for a long time. Okay, because we're going to be focusing on polynomials, multiple terms. Okay, and so this, again, is where we're going to spend our focus for today, where I have two binomials, two-term parentheses multiplied by each other. That's what we're going to focus on today. And then on Monday, we'll see what happens. What happens if I have a longer polynomial, like, say, a trinomial or something. Okay, so that'll be on Monday. But for today, I'm going to kind of start by reviewing what happens with the process of distribution. Okay, this is a problem that many of you have seen for a long time, dating back to middle school, and maybe in some cases even before. All right, so distribution. If ever I have some object, a monomial, multiplied by a parentheses, what I'm going to be doing is I'm going to be doing the operation of multiplication, but I'm going to take that front object and multiply it throughout every object inside the parentheses. Now this one has two objects. It's a binomial inside of the parentheses. It could be more. Okay, I could have 3, 4, 5, 7, 10 different objects inside of a parentheses right here that when I distribute, I'm just multiplying by every single object inside the parentheses, however many there are. Okay, so as far as showing the work for it, I take the time both in these notes and in the solutions that are uploaded on Google Classroom to kind of show the process of distribution. Many of us can kind of jump right here to the finish line. I'm okay with you doing this right to the finish line on my tests. Okay, but this is just, again, to illustrate what's happening for those that maybe this is a little foggier as far as your memory goes. Okay, so if I'm multiplying 3 times the quantity 2x plus 2, when I distribute, I'm multiplying the 3 by each of the individual objects inside the parentheses. So 3 times 2x would give me 6x. 3 times the positive 2 would give me positive 6. Okay, so this one right here should be something you're more than familiar with, that you've been doing for a long time. Right? This is essentially the process we're going to be doing in this section. We're just going to have to do it a couple more times. Okay, so that's as complicated as it's getting. It's just multiplication. Keep track of your negatives as usual. So here I've kind of added in an extra element that instead of just 3, now it's 3x. Still a monomial, still a single term. This is like what we talked about in yesterday's notes. 3x is considered a monomial. And I'm still multiplying throughout a given parentheses. Again, just a binomial. There could be more terms. It doesn't matter. But when I distribute this object, whatever the object may be, whether it's just a number like before or a number times a variable, it's still a monomial, and I'm still multiplying throughout a given parentheses. And so just like before, I'm multiplying by each object. So 3x times 2x. Now, a lot of students struggle with this multiplication right here. Number, variable, number, variable. Let me illustrate something really quickly for you guys. You can write this in your margin or something. So in this problem, we were given 3x times 2x. Okay, so my suggestion here, and this is like on the easier end of the spectrum, my suggestion here would be to kind of group your numbers together and then group your variables together next. So focus first on your numbers. 3 times 2, that's 6, right? Nothing really complicated there. And now I move on to my variables. x times x. Well, that's going to give me x squared. For whatever reason, students tend to struggle with that, where they would just think it's 6x. Well, but 3 times 2x, like in the previous example we did, was 6x. But when what happens when I have an additional variable in there? Well, x times x is x squared. Okay, now again, this is the easier end of the spectrum. What happens if I had something a little more complicated, like say something like this? 3x to the 4th times 5x squared. Okay. Well, if I had something like this, again, this is a lot more intimidating than this first example because there's more happening. But again, my suggestion here in these cases is to group first your numbers and then your variables. So 3 times 5. Well, that's easy enough. 3 times 5 is 15. Okay. Now I'd move on to my variables. X to the 4th times x squared. Again, a lot of students tend to get intimidated by this. This is actually something we did in Unit 1. If ever I had x to some variable times x to some variable, what I can do is I can just combine the variables together through addition. Okay. So that, in other words, I have 4 x's multiplied by 2 more x's. That's another way of saying x to the 6th power, or just adding the exponents together. So when you kind of break it down that way, the process is a little bit more palatable. It's a little bit easier. It's a little more easy to kind of process in your mind. So again, just do your numbers first, then move on to your variables in either case, no matter how complicated it is. Okay. All right. So let me jump back to notes. The reason I went through that is because you will be dealing. That's probably the most complicated part of this multiplying polynomial stuff. So you're going to get stuff like this, where it's like 3x times 2x. Okay, and you have to be able to deduct that that's going to be 6x squared. Don't lose track of your variables. Okay, and so when I do 3x times 2x, I get 6x squared. And then again, to finish my distribution, 3x times positive 2 gives me 6x. All right, so again, that's just the progression right there. Well, okay, now my multiplying distribution is a little more complex than before, but still pretty easy enough to deal with. So what happens when I get something like this? Now I have a polynomial, namely a binomial, a 2-term object multiplied by another 2-term object. And this is where typically when students get into math 2, this is something where it's a little more novel to them. This is something that maybe you have a little less experience dealing with. Okay, maybe you do have experience doing this kind of stuff before. And if that's the case, great. This should be a pretty deep review for you. But we're going to do a polynomial times another polynomial. But here's the good news. It's just this process again. We're just doing it multiple times. So what we're going to end up doing, I'm going to describe a method that the textbook describes as distribution method, also called FOIL method. The name of the method I actually don't care about. Whatever method works for you will be fine. Okay, I'm going to describe in a second something called table method, which is just a different way to kind of visually organize it, but it's the same thing that's happening. So whichever you end up preferring, I really don't care which one you use. And on big ideas, it will just say stuff like find the product. It's going to say use this given method, find the product using this given method, but it's not going to like force you into a structure of like use it and here's a table, fill it in. It's not going to do that. It's just going to say like, all right, find the product. So whichever method works for you, pick whatever works for you. I'm going to mostly focus on this one called distribution method or FOIL method. All right, so back to the actual solution here. I have 3x plus 1 times 2x plus 2. Essentially, this is going to break down to 2 steps. Okay, 1, distribute. 2, collect any like terms I have after the fact. That's really going to be it. So in order to do this, I'm going to start just like I did in these other ones. I'm going to start with my first monomial, my first object, which in this case is 3x. And I'm going to distribute it by multiplication throughout the next parentheses, however many objects are in the next parentheses. In this case, just 2. So I would do 3x times 2x, which again, like we did before, gave us 6x squared. 3x times 2x gave me 6x squared. Now I have to continue to distribute it throughout the rest of the parentheses. So 3x times positive 2 gives me positive 6x. And now I'm done with 3x. So now what I would do, what's different from this than before is now that I have more than one object I'm distributing, now I just keep moving to the right to my next object. So I finished with 3x. I multiplied it by 2x and 2. So 3x is done. But now I have this positive 1 that's going to be multiplied throughout this parentheses as well. Okay, so I have positive 1 times 2x. 2x. Positive 1 times positive 2. Positive 2. Right? And so this is the result of that distribution. Okay? It's just a little bit longer than before because I had more than one object I had to distribute through multiplication into the next parentheses. Okay? So I had 3x times 2x and then 3x times 2. And then just move over, positive 1 times 2x, positive 1 times 2. And that's what I got as a result. 6x squared plus 6x plus 2x plus 2. All right? So step 1, distribute through multiplication. Step 2, look for a combination of like terms. In this case, I ended up with the result. I had two separate results that involved x's. These can combine. Positive 6x plus 2x gives me 8x. And now I have my final simplified polynomial. Okay? This is called the process of distributing or multiplying polynomials. Okay? And this is really what we're going to focus on right here when I have polynomial times polynomial. Real quick, just as a little side note here, what I have in the margin, this is called table method. Some people prefer this kind of visual organization where they have like this grid that they make. If you don't like this, don't use it. If you prefer this, I'm okay with you only using this. It really doesn't matter to me which of these methods you use. Okay, but for table method, just to describe this for anyone that's interested, here at the top of the columns and here on the side of the rows, these represent, this is just the same example over here. Okay, these represent each of the parentheses. So for instance, up here I had 3x plus 1, and it really doesn't matter which one's which. But here I had 3x and then plus 1. It's just each of the monomials for each column. And if there was more than two objects, I would just make more columns. And then here on the rows, I have 2x plus 2. That's just this other parentheses. If there were more objects, I would have more rows. Okay. And basically what happens in table method, it's the same exact thing as here. It's just that now rows and columns are multiplied by each other. So for instance, here for this box, I would multiply the 3x and the 2x together. 3x times 2x gives me 6x squared. For this box, I'd have positive 1 times 2x, 2x. For this box, I'd have 3x times positive 2, 6x. And then for this last box, I'd have 1 times 2, or 2. And this basically result is this guy, the distribution. And then I would just collect like terms. So in this case, the x's would combine to give me my final answer. So again, this is just a visual organizational difference than what the distribution method is. Okay, but now let's move on to our examples. I don't care which one you use. I'm going to use this one mostly just because that's what I'm used to doing. Okay, but we're going to deal with both of these examples, and that will be it for today. So let me jump to our solutions. These solutions are also uploaded onto Google Classroom. Okay, so we're given two different problems that we're asked to find the product, in other words, multiply. And again, it's going to break down to a two-step process that I outline here. Okay, distribute, collect like terms. That's essentially what we're going to do for each of these problems. Distribute, collect like terms. So in this first problem, 2x minus 3 times x plus 5. I'm going to take my first object, my first monomial, 2x, and I'm going to multiply it. I'm going to distribute it through my next parentheses. 2x times x gives me 2x squared. 2x times positive 5 gives me 10x. Now I'm done with the 2x. So now I move on to the negative 3. Negative 3 times x gives me negative 3x. Negative 3 times positive 5 gives me negative 15. And there's my distribution right there. But now, after I've done distribution, I have to collect like terms. In here, we see that I have 10x and negative 3x. If I were to combine them, I'd get 7x. If I have 10 of something and I take 3 away, I get 7. There's my final simplified polynomial. There are no other x squareds, no other numbers. Simplified. All right, next problem. 2x plus 1 times 3x minus 5. Again, same process as before. My first object, my first monomial, 2x, multiply it throughout my next parentheses. 2x times 3x gives me 6x squared. 2x times negative 5 gives me negative 10x. So now I'm done with the 2x. Now my positive 1. Positive 1 times 3x gives me positive 3x. Positive 1 times negative 5 gives me negative 5. There's my distribution. Collect my like terms. I have negative 10x. I add 3x. I get to negative 7x. There's my simplified version. And then on Monday, we'll start focusing on what happens if I multiply by a little bit longer polynomial. Okay, but we'll deal with that on Monday. Let me go ahead and stop recording.